Retrieval Augmented Generation. This is a phrase that came around popular in 2024. RAG is a combination of technologies that will allow you to interact with a large language model that is contextually aware with the questions that you're asking it. Very often, you'll want to provide the model with data it's never have seen before. So, for example, data that's specific to your business. You can take that data in your business that's hidden in your own systems, pull it into a vector store, and then index it in specific ways that provide the ability to retrieve that data and then provide it to the large language model as context. A user asks a question, and it can be about your data. And that's what Retrieval Augmented Generation is all about. This is that technology that you combine with a large language model like a Llama 3, OpenParse to parse out the segments of the data that you're piping in. You need a vector indexer. Postgres, you need an embedding system that extracts the context, add human answers, and a full text search engine so you can have higher accuracy. SOTA, it's an acronym that states, it's a state of the art. It represents the current best known combination of technologies and techniques to build something or offer a technology source. In order to get a SOTA type system for a retrieval augmented generation, you will need to combine a certain set of technologies for the best possible outcome. Combining MetaLLAMA 3.1 or another model that matches your use case, you need to be able to parse out data from the documents that you're passing into the system so that way it can piece out segments that fit into the vector embedding window, and then you can index those vectors with Postgres, for example, and then you can also provide human-generated answers to questions that you'd also store in your vector search. You also need to index with a full text search engine, which is a keyword indexing system. This is going to represent the SOTA, the state of the art for a retrieval augmented generation system. When you're preparing documents to store into a vector search, you need to be able to parse out the documents in a way that allows them to be stored efficiently, but also at the same time, when you do a vector search for similarity and distance on the vectors, you need to have a set of data that can match more cleanly, and you want to parse out that data in segments. So that way, because if you index an entire document end to end in an embedding, then it's going to be fuzzy. It's going to be light. It's not going to be able to match with a lot of things. You want to parse out pieces of that document in a smart way, and that's what OpenParse is for. It's going to segment those documents so that way you get the best possible, highest fidelity resolution on the context that's involved within that document. So you'll use OpenParse before you throw that into an embedding layer, and this is an important part from building the RAG system. Why would you build a dual indexing system in a retrieval augmented generation? In this case, right, we've got a vector index and we've got a full text search gen index, which is like a keyword search built into Postgres, for example. You have both of these types of indexes. Why would you use both? Well, it turns out, based on the kind of data that is tossed into a vector search, it gets pretty fuzzy pretty quickly. And so you not only want to provide the highest fidelity resolution possible within those indexes in the vector search, you'll also want to provide a really high precision approach with a keyword search. So you'll want to combine both of those approaches together at the same time, so that way you get context-aware search, which is able to determine nuance in conversation. That's the vector side. And then you want exact keywords that are going to be also matching. So you'll combine both of those together, and that will be the input documents for your large language model. All right, let's walk through the process of a retrieval augmented generation system. Really, the end goal is to have a user who's able to ask a question of your business's data. So you'll have a database that has a vector search index and a full text search index. The user will ask their question, blah, blah, blah. That sentence in question gets submitted to the server, which vectorizes the user's prompt and then also extracts the keywords. It throws that into a keyword search index and a vector search index, pulling back two sets of results. You'll merge the results, append those documents into the prompt for the LLM, and you append finally the user's question. Now the large language model knows about the question and the data behind it from within your business. It can answer the user's prompt more readily with accurate data because it has that data from your business. And you get that data from the vector search and from the keyword search. If you're building a Retrieval Augmented Generation system, a RAG, that will be built into your business, this is how you would do it. You need these components. You need to follow these steps here. The RAG approach, you need to have an enhanced context by using OpenParse graphical parsing that allows to split documents to retain their context with better quality information. When you have a lot of documents in a business, you need to be able to split out pieces to vectorize, so that way when you run a vector search, you're going to get high quality results. And you also need to have a good embedding model when you're generating those in vectors. So you want like a 4K resolution model, for example, for the number of features that are the dimensions. And then for indexing, you want to combine keyword search and the vector search, because you need to have context, which is the vector, and then you need to have full text search for keywords, so it's very precise. And then you can also append human expertise with a question answer system that is built into your database as well. If you're building a Retrieval Augmented Generation system, then these are the components that you'll likely want to use. Check this out. You'll want to use a good large language model that has high output quality. MetaLLAMA 3.1 is a decent option there. You want to use OpenParse to parse out the data in your documents in a contextually aware fashion that is based on graphical positions of the data in the document. Postgres for your vector index and your full text index as well. So that way you use the gen sort of reverse keyword lookup indexing, keyword search essentially. Then you'll add a good vector. When you vectorize the data, you want to have a really good embedding system. And so NV embed v2 is a high matching system that is it ranks really high in terms of its accuracy overall. And then you want to add some human answers to it as well, so that way in your database, when you're doing a vector search and a keyword search, some human populated answers are in there as well. So you'd have the document source when you're appending it to the LLM document source, human answers, and then the user's prompt.